Okay, so let's kick off. Thank you very much for coming. I guess I just want to say a little bit about the Trusted Research Framework, explain why it is actually very relevant to what we're doing. I don't know what you feel like, because I don't know where you have in your career spent the bulk of your research energy, but as someone who comes from pure maths, it's an unusual feeling to discover that you are suddenly, doing stuff that is covered by the National Security Investment Act and various things like that. So kind of just want to start. Oh, yes, sorry. In terms of, obviously, by and large, we've met. I'm Tom Coates. I'm a professor of math at Imperial. I'm also on part-time secondment to the Office of the Chief Scientific Advisor. For absolute clarity, I am not speaking for anybody other than, I'm speaking in my hub role here. I'm not speaking as from OCSA, even though that is kind of government relevant, and I'm certainly not speaking for EPSRC. This is me in my hub role, talking about kind of my own understanding of the Trusted Research Framework, and maybe we can talk things through. So, just in terms of context, I think this is kind of obvious, but if we look at around what's happening in the world at the moment, there's a lot of geopolitical context, and in some cases there's actual open conflict, and a lot of this is kind of very relevant to what we as researchers are doing, because AI is one of the critical technologies right now, and sorry, this isn't a super nice thing to say, but it appears to be the case that kind of certain states have made decisions to kind of acquire advantage, acquire usually IP in kind of sensitive and critical technologies through a mixture of industrial espionage and, quite critically for us, taking advantage of some of the kind of open and collaborative norms around research in UK academia. So that sets the context for the Trusted Research Framework, which is the idea that, kind of a set of policies and kind of legal frameworks and so forth that are aimed at protecting the UK's sensitive research, protecting researchers, infrastructure, IP from, I guess, just quoting, potential theft, manipulation, and exploitation, including as a result of interference by hostile actors. So, this is necessary. It absolutely doesn't mean that we shouldn't be open and we shouldn't be collaborative, but it does mean we need to think things through a little bit and just be a tiny bit careful, try not to do anything naive that puts us or our colleagues in a difficult position. So, if I want to just completely spoil the surprise, like I wanted to get 3 things across. Firstly, we have to engage with the Trusted Research Framework because it applies directly to our research. It's not optional. And secondly, under basically all circumstances, for basically all questions, the answer is talk to your research office. So, if you're about to start a new international collaboration, check in with them first. And if anything changes involving kind of the direction or content of an international collaboration, or everything starts to feel weird, you should talk to your research office because they are there to protect you. And we need to be a little bit careful because I don't know about you, but I am a pretty highly autonomous individual. It's true for UK academia in general. It's particularly true for mathematics. I think as a profession, we tend to regard university bureaucracy as to be avoided and kind of like gets in the way and stuff, and we tend to do things for ourselves. That is, in this context, an extremely bad idea. as I will argue, because the situation is quite complicated and their job there is actually to protect you, not just to make your life harder. So talking to your research office is really the fundamental answer to most of the questions. Okay, so in terms of the risks we're talking about, it's about people stealing your science, right? Either your research or the commercially relevant bits of IP, but even just the research itself, or potentially you or your research group being used as a gateway through which to steal IP of your colleagues. And there's a bunch of stuff around reputational risk, which we'll talk about as well, like not accidentally doing things that turn out to be a bad idea later, and reputational risk to university. And, you know, just in terms of things that have come up in or close to my own institution, trying to avoid developing drone swarms for military institutions in traditionally adversarial states is probably a good idea. Similarly, trying to avoid getting involved in developing face recognition algorithms in collaboration with security-aligned institutions in repressive regimes. Basically, having in the back of your mind, if this landed in the Daily Mail, would it make me look bad? That's a good kind of working principle to have, right? And because of that, going back to the thing about talking about to your research office, I don't know about you, but at Imperial, when you kind of like are going to put in a grant application, there's a step in the process where you're supposed to talk to your research office to see whether it's kind of like relevant to trusted research or research security. So it's very tempting to think of that kind of that process as a gate. It's just a yes/no threshold thing that's checked at the beginning of the collaboration. But particularly with all of this stuff around reputation risk, trying to make this as more of an ongoing check and just occasionally checking in and thinking through whether you are in danger of getting yourself into an ethically compromised situation is probably a good idea. So can we do a scenario? Okay, so you're doing some AI that's relevant to face recognition. You start a collaboration with a foreign lab. You run it through your university's due diligence and shared IP, and then later on, it transpires that the institution you're working with is linked to domestic surveillance in that country. And now you're just in a horrible situation, right? Because you've potentially been doing research which is indirectly enabling human rights abuses, and it leaves both you and the university kind of rather exposed ethically, reputationally, and so on. And so I think this is in the speaker notes, and I will send this around later. There's a bunch of different scenarios that the trusted research team at whatever the National Protective Agency is currently called have developed, and this is one of them. And they don't draw out a sort of implication for this, but the implication that I would draw out here is do not roll your own due diligence, right? It's not going to be obvious to you necessarily that the collaboration you're standing up is with an institution that's linked to sort of security apparatus in whatever state it was. But your research office is supposed to know that, and even if they don't, they have access to a whole system to check whether this sort of thing is okay. So don't roll your own due diligence, ask. And the reason this is so difficult is because, the diligence here is gonna have to include downstream use, which is something that will be potentially quite hard for you to assess directly. So the whole point here, I think, is ask your research office. Just in terms of, so there, I think one could very easily have quite principled political objections to this entire framework, right? That either because of your own political views or because of a feeling that, like, fundamentally scientific collaboration should be open, that it's quite easy to feel like, well, this is all nonsense. I'm just not going to think about it. It's not appropriate. But it's quite important that you don't do that, because quite a lot of this is just the law. And, so in particular, AI triggers a lot of export control stuff if you're not careful. And export control laws are really complicated. We'll do a couple of scenarios in a minute. And so navigating this yourself, it's very easy to get it wrong. Similarly, there's the National Security and Investment Act, which regulates dual use technology in 17 kind of high importance sectors. One of those sectors is AI. So your research almost certainly triggers university reporting requirements under the National Security and Investment Act. So again, sort of failing to engage here can actually get you into genuinely problematic territory just because it's the law. And it's also part of UKRI funding conditions on our grant, and other UKRI grants are kind of compliance with trusted research frameworks. So, I guess my point is this stuff isn't really optional. For myself, I don't have a political problem with this. But I understand that there are people whose principles get implicated by this. That seems completely fine, but you need to be aware of the legal framework you work in. Can we do another scenario? In fact, could we make like smiley faces in the chat if people are reasonably speaking, following along and kind of engaged and so forth, and frowny faces or absence of things if people are. Cool. Thanks, Tristan. Aideen.
Yeah, thanks. I wanted to ask a question about like what actually constitutes an international collaboration. Like, is the trust boundary, like from what I understand, it seems like it's like within, like at the institution level, and then but then at what, like how far does it extend? So for example, if we are applying for a grant application for a company that's US based, for example, does that also constitute?
Absolutely. Yeah, absolutely. So, although the motivating cases of that led to the introduction of the framework probably involved kind of traditionally states that we would traditionally regard as adversaries, it applies to international collaborations broadly. And also, I think one could make a strong case that the world is changing, and traditional notions of allyship are also changing. But regardless of this, it applies to international collaborations full stop. So, honestly, ask your research office, because it's very complicated. And in fact, if we just do this, so just for kind of additional illustration of the complexity here, can we just sort of talk our way through this example? So yeah, imagine that your group start off collaborating with a UK subsidiary of a foreign company, right? And this is all fine. You do the right thing. You get your research office to do diligence on what you're going to do. And at some point, the company funds you to buy some equipment, let's say. So I realize we're mathematicians. Let's pretend that equipment is a bunch of GPUs, right? So they fund you. Please go source some H200s, right? And then halfway through, the direction of the research project changes. Please, could you send the equipment back? In fact, can you send it to the parent company, Foreign Co, right? And now you need to be awfully careful, because if, for example, Foreign Co is under sanctions or subject to export controls, you will just have violated export control law by doing that, right? Didn't mean to, but what you actually did was you routed specialist equipment that was not supposed to be accessible, that was covered by export control law to the entity that wasn't supposed to receive it. So this is, yet again, in circumstances like this, talk to your research office, because otherwise you can potentially get yourself into fairly thorny legal trouble. This is a silly example because most mathematicians don't use equipment, right? Like maybe chalk or possibly, compute credits or something. But it's worse than that, right? Let's just make this example slightly more realistic, right? The definition of export here is really incredibly broad. It includes, for example, emailing data to scientific collaborators abroad, touches export control. So, suppose this is the same setup, but your research group, again, starts this collaboration with the foreign company, due diligence, everything's fine, you do a bunch of model training or whatever, and then at some point you're halfway through validating the results, and the subsidiary asks you to kind of like either send data or send model weights or give access to model weights to scientists from the parent company. You need to be super careful, because under quite a lot of circumstances, that's going to touch export control law again, right? So exporting it doesn't need to involve physical stuff. It can just involve know-how or scientific kind of capability. So the unique point of this talk is ask your research office. They, in situations like this, just like be super careful, because even if it's innocuous, you want to be in a situation where you have gone through the process to demonstrate that this is fine. Okay, so again, if it is regrettable, but there have been several cases of nation-state campaigns where that are kind of looking to acquire IP through cultivating connections with UK academic labs, right? So just in terms of things that should make you feel that you should be extra careful about asking for help. Funding that looks generous considering the scope of the research. Scope of the research which is kind of changing over time. If you have multiple project partners, or if you have multiple projects going on, just you potentially want to think a little bit about segmenting who has access to what, so that giving people access to one code base doesn't give access to everything in your partner's data as well. And then obviously anything that's dual use or military, particularly around kind of model verification, model inversion attacks, whatever, you use your own judgment here, but kind of dual use research and military research, research with military applications is an obvious target, and also just commercially valuable stuff. At the risk of laboring the point, it might be possible to overlook the commercial value of some of the things we do. So, for example, in my group, we just spent a bunch of time doing model training on Dawn, which is the Intel's, which is the AIRR supercomputer that's based on the Intel stack. And that was a ginormous pain in the behind, and it involved, a whole lot of learning about how to effectively get models onto Intel hardware. Just that's not kind of protectable IP in any way. It's certainly not going to result in a paper, but it's potentially actually seriously commercially valuable. The kind of those workflows, those kind of pieces of information about about how to kind of how to get machine learning models running effectively on Intel hardware. That is something of potential commercial value. So again, you should be you'll have a huge amount of stuff lying around of this form, I suspect, and you should be kind of thoughtful about it. And in terms of why you should ask your research office, so partly they'll have much more experience, but they also have access to a system for helping them here. There's what's called the Research Collaborations Advisory Team, which currently sits inside DCERT, and they have access to kind of non-open source material, and they also have kind of sight of collaborations that are going on across the whole country. So they're in a position to give better advice on sensitive research and so forth, about how to proceed, whether, both to say, yes, that's fine, don't worry, and also to say, we would proceed with caution and we suggest the following mitigations. So asking your research office is partly a good idea because they're supposed to protect you and they're going to be in a position to know, but they also have access to kind of government side expertise that every research office will have an RCAP contact point. And so they can kind of call on more relevant expertise if they need to. That was really everything I had to say. Don't know if people have questions or comments, but just going back to the whole point, like, despite the fact that many of us are mathematicians, the fact that we work on AI means we are touched by the trusted research framework, whether we want to or not. And that means that the answer to almost all questions is talk to your research office, like partly before starting a new collaboration internationally, and check in every so often, and check in particularly if things change. They're there to kind of help us not get ourselves into a situation where we've accidentally compromised either our ethics or our reputation. And most of the time, this is all fine, but you should be aware that, even if we are fully committed to open kind of sharing of academic work in terms of our own values and norms, that does leave us potentially exposed in some circumstances. And so we should think this through moderately carefully. Yeah, so I don't know, questions, comments? Hey.
Thanks. I had a question about whether like software open source libraries fall into scope of the trusted research framework.
Can you give me a bit more context?
So why I was thinking about this was that yesterday or the day before, there was it was found out that a very popular PyPy package called Light LLM, it has like 100 million downloads a month, had a supply chain vulnerability in it, which basically just like on download, it would search for any credentials on the local user's environment, and everything from like crypto wallet stuff, SSH keys, everything. And so it seems like because these like PyPy packages, other things are used within like the implementation of stuff that seems like it is in scope of this, it would also be, but that's super difficult because it's not like there's a trusted dependency tree that would safeguard against this sort of thing, or even yeah.
So I think, so my understanding of the framework, and I think the key takeaway is at any point, just hand it off to the people in your university who are supposed to know about this. Ask your research office. My understanding is, though, that wouldn't be in scope because this isn't about kind of covering all security risks to research. Obviously, cybersecurity is a big one, right? And there's much to be said for having secure in kind of appropriately segmented and partitioned internal setups, kind of doing as much zero trust as you can. But it's not. But I think trusted research is not really about that. It's largely about kind of controlling researcher activity, researchers' choices. I mean, obviously, intentionally putting a backdoor in a software package would certainly be misconduct, but I don't think that's implicated by the framework here.
Okay, thanks.
Yue.
Sorry, unmute noise. Okay, yeah. So, but coming back to the open source software, what about the other direction? So, what if you implement something and you kind of make it open source, because in part UKRI also demands that, right? So they have their open research kind of thing, and now somebody takes this and does something really, really bad with it, because I don't know. Let's say you develop a library for multi-path agent pathfinding. Multi-agent pathfinding, and you think about like robots in a logistics center, somebody else thinks about a drone swarm for, let's say, the Chinese military.
Yes, absolutely. So, and I do think, so yes, and that feels like a kind of classic piece of research that is dual use, but is not obviously dual use. Absolutely. So, and there is a real tension between the kind of push towards openness, and which is like, you know, correct behavior in many ways, right? It's like super valuable into the whole culture of academic research is really premised on a lot of openness, but that does seem like the sort of work that you should be talking through both with your research office and with your funders, how the outputs of that are kind of are made available. Should it be open source? Yeah, it's probably fine, right? I mean, it is kind of a difficult situation, right? If you performant algorithms for operations on graphs, for example, have any number of nefarious applications as well, right? So, you know, if you go far enough back up the, so I think, you know, we can't possibly hope to, and it wouldn't be correct to try to kind of prevent all bad downstream uses, but you kind of want to have done that in an intentional way, like thinking it through. Okay.
Thanks.
So I think that's a really sharp example. If it's okay, I'll steal that for a later iteration of this talk. It's yeah, because that is like something where, you know, many benign applications, many potentially difficult applications, and yeah, the type of thing that many of us might well be working on.
Yeah, I mean, that's also, I think, more really a big problem with, I guess, computer science, but also like particular mathematics. It's just like, we work on stuff that can be applied for all sorts of things, and it's very difficult to control, you know.
100%. Yeah. There's no such thing as pure mathematics, right? There's only pure mathematicians.
Yeah. Okay, thanks.
Cool.